Hi everybody, my name is Jacob Arnold and I teach math models and geometry. Now I know that one course, math models, there's a lot of confusion about the course because it's hard to find resources and materials out there that actually align with the TEKS, the Texas Educational Knowledge and Skills that the students are supposed to know. So what I'm doing is I'm going through and I'm kind of creating materials on my own. So in the first week, one of the things you have to cover, if you have to go by TEKS resource, which is a great resource out there, one of the things that I'm doing is in the first section or unit, you have to cover how proportionality connects to sports as well as sciences. So the first TEK that you look at says that you need to talk about Newton's law, and you got to talk about Hooke's law, as well as Boyle's law. And today what I'm going to do is I'm going to show you guys how you can use Boyle's law to connect it to mathematics with your students. So Boyle's law states that if you keep temperature the same, constant in your experiment, then your pressure and your volume should remain proportional, or I'm sorry, inversely proportionate, meaning that if one goes up, the other has to go down, because that equation is pressure times volume equals K, your constant. Okay, so here's what I did to try to show that to students. So right here, what I've done is I've taken a 2-liter bottle. I had my kids drink all the soda that was in it as fast as they could. And then what I did is I took the lid off of the bottle and I drilled a hole in the top of the lid. And then I took an old bike tube and I cut off the valve and I superglued it into the lid. That way the valve came out of the top of the lid. And then I took a balloon, uninflated obviously, and I stuck it inside the 2-liter bottle. And I took a straw and I put it in there with it, because if you don't put the straw in, you're not going to be able to blow up the balloon. The balloon will go a little bit, but it's eventually going to block your airway and you're not going to go anywhere. You're just going to sit there and turn red. So anyways, you blow up the balloon, you tie the balloon, and then you put the lid back on. Okay, so the next thing that I did is I put these little hash marks along the side of the balloon. What I did is I took a ruler and I put it alongside, and all these long marks represent an inch. And every dot in the middle represents a ½ inch. Okay, so the reason why I did that is because in Algebra 1, high school students are taught how to find volume of a sphere, or at least they're supposed to be. So anyways, once you blow up the balloon, you can kind of estimate what the initial volume of the balloon is, based on what you have there because of that. Then, after you perform the experiment, you can try to find the volume again because of those hash marks being there. It gives you a way to measure what's inside the balloon. I'm sorry, the bottle. Okay, so again, the whole idea behind this is that we want to force air into the bottle and show them that as you increase the pressure in the bottle, something's going to happen to the balloon. There's a fixed amount of air in that balloon, and that's not going to change. That balloon acts like a barrier around all of the air that's in the balloon and allows us to manipulate that once we put it in a fixed environment. Okay, so again, we're going to increase pressure, and according to Boyle's law, we expect volume to decrease. So volume decreasing means that the balloon we expect should get smaller. So let's test that out. And I've got a bike pump here that I'm going to connect to this valve. Okay. And now we just need to pump some air in. And as you can see, the balloon is getting smaller as we put more and more air in here. So, as we expected, the volume of the balloon did get smaller. Now, when I screwed the balloon back on, when I take the lid off, we should expect that that balloon should get larger again. Now, in most cases, balloons normally resemble a sphere, okay, but in this case, you can kind of estimate, because most of the stuff that we have to do in mathematics is estimation, just so we can get an idea of how the concept works. Anyways, so if we let the air back out of the bottle, we would expect that the balloon would get larger again, because as we pushed air in, it got smaller. So as we take air out, we expect the opposite reaction. Now again, recall that the Boyle's law gives us the equation pressure times volume is equal to that constant. So what I'm going to do is I'm going to take this balloon and I'm going to put it back down here. And then with my class, I'm going to take this lid off and show them what happens. If you want to find out, build it yourself.